Welcome. Today we'll learn how to draw the Lewis dot structure for potassium chlorate, or KClO3. Let's break this down step by step. First, let's count the total valence electrons. Potassium has 1 valence electron, chlorine has 7 valence electrons, and each oxygen has 6 valence electrons. With 3 oxygen atoms, that gives us a total of 1 plus 7 plus 18, or 26 valence electrons. Next, let's draw the skeletal structure. Chlorine will be our central atom, since it's the least electronegative non-hydrogen atom. The 3 oxygen atoms will be bonded to chlorine, and potassium will be written separately as it forms an ionic bond. Now, let's add the electrons. Each single bond represents 2 shared electrons. We have used 6 electrons for the 3 bonds. The remaining 20 electrons need to be placed as lone pairs. Each oxygen gets 3 lone pairs, and chlorine gets 1 lone pair. Finally, let's calculate the formal charges. Remember, formal charge equals the number of valence electrons minus the number of lone pair electrons minus the number of bonding electrons. For chlorine, that's 7 minus 2 minus 6, giving a -1 charge. For each oxygen, it's 6 minus 2, giving a formal charge of -2. Potassium forms a +1 ion. And there we have it, the complete Lewis dot structure for potassium chlorate. Notice how the formal charges balance out to 0, confirming our structure is correct.